Hello, happy Friday. So today we are doing the next part of section 5.3. You should have your notes handy. We'll go through them together. On this part of 5.3, we're going to build off of what we did on block day, where we are going to factor and solve these equations for x. We're going to be finding the angles that make the equations true. The problem that we're going to now have is that, see, we can try to go ahead and factor this. We would need to set it equal to 0. So let's see, go ahead and take away 4 cosine squared x from both sides. Because before I can factor to solve it, it has to say equals 0. But here's the problem. Now I've got cosine squared, I've got sine squared. This is a trinomial. I can't factor that because they're not the same terms. So what we're going to do is we're going to build off of the identities that we had been studying last week that we just took a quiz on. And I'm going to switch out, I'm going to substitute one of these identities so I have only the same trig identity or trig quotient. So since cosine squared is equal to 1 minus sine squared, I'm going to switch that one out. I'm going to make it -4, 1 minus, 1 minus sine squared. And then I still have minus 12 sine x plus 9 equals 0. And now I'll go ahead and distribute and simplify. Combine some like terms, reorder this. 4 sine squared x minus 12 sine x, and then plus 5 equals 0. Now it's in a better order, and we have all signs, so we can factor this. Let's see. Guess and check. There's not a GCF. Guess and check. 2 sine x, 2 sine x. This is plus 5, so it's got to both be the same sign. They're both going to be minus, and I have to get 12 when I'm done. So if I do 2 times 5 plus 2 times 1, then I'm going to get that -12. So I have it factored, set each factor equal to 0. And this should be what we've already learned. Let's see, 2 sine x is 1 divided by 2. We get sine x equals a half. And that's at 5/6 and 5/6. Over here, I'm going to add the 5 to both sides. I'm going to get 2 sine x equals 5 divided by 2. I get sine x equals 5 halves, or 2.5, 2.5. And sine can never be over 1. The highest it can ever be is 1. So this is undefined. This is useless information. I'm not going to use that one. So I only have 2 answers. I would highly encourage you to check your answers, especially because I'm not there to kind of make sure you're on the right track. Check your answers. It's easiest to do with Desmos. I've already put these in, so I'm going to pull that up. You can see what the graph looks like. We can check our answers together. And between 0 to 2 pi, it only crosses twice at pi/6 and 5pi/6. So I now have the correct answer. All right, next example. 2 tangent squared x minus 3 secant x plus 3 equals 0. And I look at these, And I've got tangents, and then I've got a secant, and those aren't the same, so I can't factor it. But I do know that there is some sort of identity to make it a little bit easier on me. Let's see. Right here I've got tangent squared is equal to secant squared minus u. I can't switch out secant because it would have to be squared. But I can switch tangent squared to secant squared u minus 1. So that's what I'm going to do. Substitute. Secant squared x minus 1. Minus 3 secant x plus 3 equals 0. I'm going to distribute that 2. Combine like terms, make sure it is in quadratic form so we can factor it. Okay, we've got a trinomial, no GCF, so I'm just going to factor by guess and check. 2 secant x and secant x. This is over here is a plus 1, so both signs are the same, and they've got to be 1. Both signs have to be negative to give me that negative 3. If you're not sure if you're factoring it correctly, you can boil it back together to check. Once you know it's factored correctly, we're going to set each factor equal to 0. And solve each factor. So I have secant x equals a half. I don't have my secants memorized, so I'm going to change that into cosine. So where is cosine x equal to 2? Never is. So don't need any of that information. Over here, where is cosine equal to 1? Well, that is just at 0. So I only have one answer. Just want to make sure that I'm doing it right, build up my confidence and my skills. I'm going to check it on Desmos. Okay, when I'm looking at Desmos, there is an x-intercept at 0. There's also one at 2 pi, but in the directions, it specifically says you can use 0, but do not include 2 pi. So we're only using 0 for our answer. So just one answer, 0. Okay, the next one. These are not squared, so I cannot use the Pythagorean identities, and they're also not the same, so I can't factor anything. I can set it equal to 0, but it's not going to help me at this point because I can't factor anything. So I think I'm going to try using the other fundamental identities. Cosecant x is 1 over sine x. Cotangent x is cosine x over sine x equals 1. Ooh, and then I see I have a common denominator. So I'm going to go ahead and add those together. All right, I get 1 plus cosine x over sine x equals 1. And I need to solve this. I need it all to be sines or all to be cosines so I can factor to solve it. So I'm still working on that. I think what I'm going to try to do is put 1 over 1 and cross multiply. You'll see why I'm doing that. You're going to know to do something like that by experience. I'm showing you, for the first time. So I'm going to cross multiply. I'm going to get sine x on one side. And on the other side, I'm going to get 1 plus cosine x. And why I did that is because since we have an equal sign, it does not matter what I do to either side. As long as I do the same thing to both sides, it stays equal. So what I'm going to do is I'm going to square both sides. When I square both sides, on this side I'm going to get sine squared x. On this side I have to FOIL it to square it. So we're going to have 1 plus cosine x multiplied by 1 plus cosine x. You're going to use your FOIL method. I already know how to do it in my head, so I'm going to do it quickly. But I'm going to get 1 plus 2 cosine x plus cosine squared x. Now when I look at this, there's a lot more cosines than there are sines. So I'm going to use my Pythagorean identity for sine squared x. It says that sine squared x is equal to 1 minus cosine squared. So I'm going to switch, I'm going to use substitution here. I'm going to get 1 minus cosine squared x equals 1 plus 2 cosine x plus cosine squared x. And now I have all cosines. So now I'm going to start to factor it and solve it. So I need it to say equals 0. Let's see. I think I'll move that stuff over. I think I'm going to subtract 1 from both sides. Oh, good, those cancel out. And I think I'm also going to add cosine squared x to both sides. So I get 0, and these cancel out. 2 cosine x plus 2 cosine squared x. And I'm going to try to factor this, and I notice that there is a greatest common factor of 2 cosine. So I'm going to divide out 2 cosine x, and I have left over 1 plus cosine x. And now I have it factored, so I'm going to set each factor equal to 0. And I'm going to divide this side by 2, and we get cosine x is 0. Well, that happens at pi over 2 and at 3 pi over 2. Over here, cosine x equals negative 1. That happens at pi. Excellent. I have 3 answers. I'm going to go check my answers. And I'm telling you right now, I've left all this extra space over here because you're going to see what's about to happen. I'm going to go check my answers on Desmos. Okay, so I checked my answers, and there's only 1 answer. I got 3. So why did that happen? Why? Back here, when I squared both sides, I was putting in more x's than the original question. And when we think about degree and how many solutions there are, in the original question, there was just an x to the first power for all of these. There really should be only 1 solution. But when I put in the squared, I was giving it more solutions. So what I have to do when I do things like square both sides is I have to check my answers, and I have to see if any of them were kind of extra answers that I got when I squared it, but they're not actual answers from the original question. So if I didn't have Desmos, I would need to, when I'm going to do it right now, you need to plug each of these into the original question to see which ones work and which ones don't. So see what happens when we check our answers. So I'm going to check them in the original, but I'm going to check them in the one with the sines and the cosines. These are exactly equal. This is before I squared it, so I can check it in this one too. So I'm going to do 1 over sine, and my first angle is pi over 2. Plus cosine at pi over 2 over sine pi over 2 equals 1. So I'm going to plug that in. And let's see, sine at pi over 2 is 1. Cosine at pi over 2 is 0 over 1. So I get 1 plus 0 equals 1. That one checks. And you saw on Desmos, that was the one that worked. So let's see what happens when we plug in 3 pi over 2. 1 over sine at 3 pi over 2 plus cosine 3 pi over 2 over sine 3 pi over 2. I guess I could have checked it in this equation too. Anyway, has to equal 1. Now sine at 3 pi over 2 is negative 1. Cosine is 0, sine is negative 1. So when I add these together, I get negative 1 plus 0 equals negative 1, or equals 1, and no, it does not. That one does not check. And then my third one, pi, 1 over sine at pi plus cosine at pi over sine at pi. See, sine at pi is 0. So I already know it's not going to work because that's undefined. What's cosine at pi? Negative 1. I don't have to keep going, but I felt like it. There you go. So that one does not work. So our only solution is pi over 2. Okay, next example. Hopefully these become a little bit easier as you do them more. I'm looking at this and I want to factor to solve it, so it already says equals 0, but I've got sine squared and I've got cosine. I can switch out the sine squared by substitution. I'm going to have to leave the cosine because it's not squared. So I'll have 2, and I'll have 1 minus cosine squared x plus 3 cosine x minus 3. I'm going to collect my like terms, put it in the correct order. Negative 2 cosine squared x plus 3 cosine x minus 1. Anytime I have a negative out front, I just feel like it makes it harder for me to factor it. So I'm going to factor out the negative 1 before I even start. And then I'm going to factor the trinomial that's left by guess and check. Set each factor equal to 0. Solve. Where is cosine x equal to 1/2? That's at pi over 3 and 5 pi over 3. And where's cosine x equal to 1? That one would be at 0. So I have 3 solutions. I did not do any squaring of any kind, so hopefully these are all the correct answers. If I'm unsure, I can always plug it back in and check it. I'm going to check it on Desmos. You can always check it by hand if you do not have Desmos. So I'm going to pull up Desmos. And at 0, at pi over 3, at 5 pi over 3, there are solutions that are x-intercepts. There's also one at 2 pi, but that one's not included in my solution, the domain restrictions for the solution. All right, last example. Okay, so no squareds here. So I guess I'm going to make these both into sine. So I'll have 2 sine x plus 1 over sine x equals 0. And that would be over 1. Now, I did this one a couple times before recording these notes, and I fooled around with a few different ways to do it. I felt like the best way for me to solve this one would be to subtract 1 over sine x to the other side at this point. And it's very possible that you will try something and decide that wasn't the best way. And then you'll have to erase and start again. It happens. I had to do that myself on these notes. So after I did that, then I cross multiplied. And when I cross multiplied, I got 2 sine squared x equals -1. So at this point, I've already almost solved it. I just have to divide by 2, and then square root both sides. But if I square root, I gotta put the plus minus. So I get sine x equals plus minus, and I'm gonna have, oh no, what is this? A negative under a radical. Well, that's not a real answer. It's imaginary. What does that mean for my graph? I have an idea. I'm going to go look on Desmos. I'm going to see what this graph looks like. So you can see I graphed it, and this graph never crosses the x-axis, at least from 0 to 2 pi, definitely not. And if I zoom out, you'll see it never crosses the x-axis. So there are no solutions. That's why I got this imaginary answer, because there are no real solutions. So we would say no solution. Now, I know we can't, you can't ask questions because I'm obviously not in the room right now, but definitely try your best on the homework. Bring questions Monday. We'll go over it together, and we'll grade the assignment that was due Friday. We'll grade that one on Monday. And then this one, if you have questions, we can go over that. But we will be going on and learning more at 5:30 what's next in your notes packet on Monday also. I hope you have a great weekend, and do your worksheet, just 1 through 6 for homework, and I'll see you on Monday. Bye!